Now, dear students, we can discuss the effect of catalyst on the rate of reaction. What do you mean the term catalyst? So write down effects of catalyst. You know catalyst, what is catalyst? Catalyst is a chemical substance which can alter or change, which can be in positive or negative, the rate of reaction without decomposing itself into anything else. So, a substance which can alter and change, alter the rate of reaction and provide suitable path to form the products, to form the, what is that? To form the products is called catalyst. Just imagine, if you want to decompose potassium chlorate, right? Absence of the catalyst, absence of catalyst, no reaction. But if you use manganese dioxide, it will be decomposed to form 2KCl plus 3 times O2. Just you understand the impact of catalyst on the rate of reaction. Usually the phenomena is called catalysis. We will also discuss the type of catalysis in surface chemistry. That will be my next chapter. Before that, catalyst is a chemical substance which can alter the rate of reaction and provide a suitable path, and catalyst remain unchanged during the course of chemical reaction. So dear students, what is the role of the catalyst on the rate of reaction? So catalyst can form intermediate state, or you can say transition state before the products. What's the purpose of that? To minimize the activation energy. Otherwise, activation energy has such a huge energy that forms the activated complex, and the products are not very significant or useful. As a result, chemists or scientists have a parameter to make the best use of catalyst. Therefore, catalyst plays a significant role in various analytical, industrial or pharmaceuticals chemistry. Dear students, in this way, catalyst can form intermediate. For example, if I say reactant, or that gives the product, but before that there is a here intermediate stage which act as a catalyst here. So if you want to say H2 plus I2, that gives 2HI. So these are the reactants and these are the products. Whenever these two combine together, HH and II, there is a bond, and that bond is temporary bond. It is in fact intermediate stage, and finally HI is formed, products are formed. So it is what actually reactant and the products, and in between there is an intermediate which accelerates the rate of reaction. That is why we can plot a graph through which we can understand what the impact of catalyst on the rate of reaction. So write down graph for the catalytical reaction. If you want to say reaction coordinate, profile of energy, that is reaction coordinate right now, and this side it is the, you can say, potential potential what? Energy, right? So, dear students, it is the reactant, form the product here. So this is the reactant and this is the product. This is the reaction coordinate, profile of energy change and direction of the reaction. And this way it is what? The path. This path, mean probable kinetic energy. This is what actually at the time the path without what? Catalyst. That time it is the activation energy. And then once you provide a catalyst, so this path is with catalyst. So what is the impact on the rate of reaction? Just to think over it. So once we have provided the catalyst, the activation energy becomes lower. Whenever there is no catalyst, the zone or the path where there is no catalyst, where the activation energy becomes very high. But here we can say this is the activation energy, and that is the small area, minimum surface area that is going to cover. So the catalyst, what do? They can alter the rate of chemical reaction and provide a suitable path to form the product. Is it clear to everyone? So effect of catalyst and the effect of temperature, the way you can explain, activation energy. There is students, what do you understand by the term activation energy? Activation energy. So write down activation energy. The energy, write down everyone, the energy which is needed, the energy which is needed to form intermediate is called activated complex or transition complex, and the phenomena and the process and the energy is called activation energy. And energy is called activation energy. To explain it, let us consider a binary reaction. For example, H2 plus I2, that gives, what is that? 2HI. This is the reactant side and this is the product side. Before the product, what I have told you the word, the catalyst can provide a intermediate path. Secondly, activation energy is here like this, H plus H, I plus I, it is the intermediate stage. This is called activated complex. Activated complex, the bond is going to break and H and H, iodine and iodine going to combine to each other. So this is collision takes place and imaginary bond is formed. This is called as what complex? Activated complex. And after that, going to break Hi plus Hi, or you can say 2Hi. So activated energy means the minimum energy or energy which is needed to form the activated complex is called activation energy, and then product is formed. To check the activation energy, what we have provided, what the heuristic or parameter, that is known as catalyst, which I have already explained. The impact of catalyst on the rate of chemical reaction. Actually, this is the main area of the chemical kinetics. My dear students, in this way I can plot the graph between potential energy and reaction coordinate so far as activation energy is concerned. My dear students, here you write, here reaction coordinate, profile of energy, reaction coordinate, and this side you write what energy, potential energy, and then this is the reactant, activated complex, it is what? Activated complex, and then the area which is very maximum energy is attained at this time and equilibrium is attained, and then products are formed, H2 plus I2, that gives 2HI. This is the reactant, this is the product, and this area is the, what is that? This area is the activation energy. In order to check this activation energy, what we have provided? The catalyst. That is why I usually ask questions in different years and the CBSE paper, the effect of catalyst on the rate of reaction, activation energy on the rate of reaction, as well as you can say the temperature on the rate of reaction. In that temperature we have explained what is temperature coefficient, the ratio between the rate constant at two different temperatures differing by 10 degrees is called temperature coefficient. Now dear students, the last part of this chapter is collision theory of reaction rate. May I proceed now? Collision theory of reaction rate? Okay. So write down collision theory of reaction rate. Every collisions not able to form the products. Some collisions always used to form the product. Therefore, collision is of two types. One is the effective collision. Second is what is that? Ineffective collision. Effective collision can form the products. Ineffective collision cannot form the product. So they have to face two barriers, energy barrier, and what is that barrier? Orientation barrier. My dear students, energy barrier means, you can see the minimum energy needed is the activated energy, which is activated complex. What is the orientation barrier? That means more the symmetry of collision, faster the rate of reaction. So this is the orientation barrier. Symmetrical orientation, symmetrical collision is more important rather than unsymmetrical collision. I give you one example here. Let you explain. Whenever methyl bromide is made to react with aqueous NaOH or KOH to form what? Methanol or methyl alcohol. My dear students, here I give you CS3Br, bromomethane plus aqueous NaOH or KOH, KBr is lost here, and what is that? Methyl alcohol is formed. So here, by taking this reaction, I try to explain myself what is the orientation barrier or symmetrical collision of the reactants that plays a significant role in order to explain the effective collision. My dear students, let us write here, it is the methyl CH3 and Br, right? It is delta positive and it is delta negative because bromine is more electronegative than carbon. You have done in 11th class. Now here OH, nucleophile. It is also, bromide is also nucleophile. So therefore, in this way, a bromine and this OH react together in the same way. CS3, CBr, delta negative, delta positive, and whenever OH is near to this side, so this will repel to this side and this will repel to that side. Same charge going to repel to each other. As such, here no reaction takes place. Because why? Because of collision is not symmetrical, not perfect, it is unsymmetrical. So what is the right way to form the products? What the right way of symmetrical collision of the reactants? In this way, here I have to write here CH3, and this side I write here nucleophile, and imaginary bond is the OH. So this is the intermediate because of 1, 2, 3, 4 and 5. So it is intermediate stage, and after that product formation takes place, COH, and that is what it is, sorry, CH3, and what is that? Methanol, right? And bromide ion will be slowly and slowly out of the reaction. So this is the, proper collision. It is the proper collision and proper products are formed. This is what actually already explained in your NCERT book. Methyl bromide has two types of the collision. One is the improper collision and other is the proper collision. Proper collision requires mechanism, and therefore once we will discuss in organic chemistry, it will be the part of the SN2 reaction because it is the primary halide follows substitution reaction of nucleophilic second order. But this time it is not appropriate to explain SN2. It is very much dealt in your haloalkane and haloarine chapter, the first chapter of the second book, that is organic chemistry. Right. This time you will discuss only this part.